All right, so this is day 2, week 11, and definitely glad that each and every one of you are here. Remember that as you enter, please place here or present in the chat box to indicate that you're here. Again, please place here or present in the chat box to indicate that you are here. No, sorry, not in this chat box, inside my WhatsApp chat. All right. Okay, so yeah, remember this essay from yesterday. Oh wow, that was intense. Right. Okay, so all right, so the last thing we did was we was on, excuse me, we was dealing with this volume thing, the volume of this silo. So what we did is we found the volume of the cylinder, and then we found the volume of the hemisphere. I wonder if that's the last question that we did before we transition over to English. No, oh, the last thing we did was we was doing interest with Mr. Daniel. That was the last thing. All right. Okay, so let's continue. All right, good. So let's move on to number 4. So we already did the simple interest problem, and we did this one, the determining how much it costs to mail for the cost of mailing. And so now we should be coming down to the end of this paper. All right, so let's do number 1. Find the value of the following. All right, so let's do it. So the first question that we're going to consider is this one. So we need to find the value of, 5 to the 3rd power minus the square root of 100. All right, so any ideas on how to do that?
You want to find what 5 cube is first. Then you have to square 100, then subtract it.
Okay, subtract it. Okay, so let's do that. So what is 5 cubed?
125.
Okay, so 5 cubed is going to be 5 times. So we're going to write 5 times 5. Sorry, we're going to write 5 3 times, right? So it's going to be 5 times 5 times 5. And we know that 5 times 5 is definitely 25 times 5. And 25 times 5 is 125. Alright, so that's 125. The next thing is we need to figure out what is the square root of 100. And when we say the square root of a number, what do we mean?
What times what is 100?
Yeah, so what times what gives us 100?
10 times 10.
Okay, 10 times 10, so the square root of 100 is 10. Okay. Alright, so we have the square root of 100 is 10, 5 cubed is 125, and then so since we already know what is the square root of 100, we already know what is 5 cubed, now we are prepared to do our problem. So we have 5 cubed minus the square root of 100 is going to be equal to 5 cubed is 125, as we saw right there. Minus the square root of 100 is 10. And so we have to do 125 minus 10.
115.
What'd you get? 115? So 125 minus 10, 5 minus 0 is 5. 2 minus 1 is 1. And 1 minus 0 is 1. It's going to be 115. So the correct answer here is 115. Alright. So that's how we would do that. Any questions on how we got that?
Yes, I have a question. How did you find the square root of 100 again?
So we ask ourselves what number times itself would give us 100. So like what number I can multiply it by itself to give me 100. So we know that 3 times 3 is 9, that's not 100. 4 times 4 is 16, 900. 5 times 5 is 25, 900. 6 times 6 is 36, 900. 7 times 7 is 49, 900. 8 times 8 is 64, 900. 9 times 9 is 81, that's not 100. But 10 times 10 is going to give us 100. That's how we got 100. So that's how we know that the square root of 100 is 10.
Okay.
Alright, anyone else? Okay, so let's move it. Alright, so we already found the value of so please write down these notes, and when you're done, send a picture of it to me, please.
Can I get your number again? Because I don't have my phone, so I can't get the number right now.
Okay, I can put it in the chat right now. That's 428-8971. 428-8971.
Okay, thank you.
No problem. Alright, so the next question is dealing with this bus. I guess this is something to do with elapsed time. Let's see. It says a bus leaves the station every 20 minutes. The first bus leaves at 8:55 a.m. At what time is the third bus scheduled to leave the station? So every 20 minutes a bus leaves the station. The first bus left at 8:55. At what time will the third bus leave the station?
I know.
What'd you say?
I know.
Go ahead. What's the answer?
8:35.
8:35? No.
Would it be 8:35?
No, it wouldn't be 8:35. So every 20 minutes a bus is gonna leave.
Oh, never mind. 8:45.
So the first bus left at 8:55. That's when the first bus left. And we know that after 20 minutes, so after 20 minutes, the second bus is gonna leave. For 20 minutes, sorry. It's supposed to be S. So after 20 minutes, the second bus is going to leave. So we need to figure out what is 20 minutes from, what is 20 minutes added to 8:55. So if we have 8:55,
Good afternoon.
what we could do is we know that 20 minutes, right? 20 minutes, we can express that as
8:15.
8:15. Who said 8:15?
9:15.
Gabriel. Oh yeah, 9:15.
9:15. Good.
I didn't change the hour. Sorry about
Oh, you didn't
that.
change the hour. Okay. So we know that 20 minutes, we could write that as what? 5 minutes plus 15, right? So if we have 8:55, and we add 5 minutes to it, well, that's gonna give us it's gonna give us 9 o'clock. And then we have to add another 15 minutes to it again.
Yeah, I get 9:15 too.
Yeah, and that's gonna give us 9:15, right? So 20 minutes. So the first bus is at 8:55 a.m. And so the second bus is gonna come at or it's gonna leave rather at 9:15. But they didn't ask us for the second bus. What bus they asked us for? The third one. And so we need to add another 20 minutes because every 20 minutes a bus leaves. So what time will the third bus?
9:35.
So that's gonna be 20 plus 15. We gotta add 20 minutes to 9:15. So this is gonna be the third bus.
9:35.
Yes, ma'am. The third bus is gonna leave at 9:35 a.m. Okay. 9:35 a.m. So the correct answer here is 9:35 a.m. Again, so let me just go over this one. It says that a bus leaves the station every 20 minutes. Then it says the first bus leaves at 8:55 a.m. At what time is the third bus scheduled to leave the station? So the first bus left the station at 8:55 a.m. And then after 20 minutes, the second bus is going to leave the station, which is going to be 9:15 a.m. Then after another 20 minutes, the third bus is going to leave the station, which is going to be at 9:35 a.m. And so that means that the third bus is scheduled to leave at 9:35 a.m. So write down the question for me. I write down the working that I provided and send the picture for me. Thank you, Ms. Reckley, for sending it already. Just waiting on the others to send as well. Let me know when I can move it. All right, let me know if we finish. Are we ready to move on to the next one?
Yes, sir.
Okay. All right, so okay, so let's begin. All right, so okay, so let's continue. Let's move on to this one. This is number 11. So this one, we're trying to find the total surface area now. So what they ask us, or what they give us, is they give us this shape. Again, it's made up of two shapes, a cylinder and a sphere. All right. Yesterday we found out what is the volume of this shape. Now today they want us to figure out what would be the total surface area of this shape. Now to do that, again, anyone have any ideas in terms of finding the total surface area of it? Any ideas?
Measure the next
We'll multiply the two shapes.
Not multiply.
Add the two sides. Add all the sides together.
You're very close, Miss Sanders. What you do is you so we want the total surface area. So the total surface area means that we want the area of the surfaces. So we have to figure out what is the surface area of the cylinder, and then what is the surface area of the sphere, of the hemisphere, really, because it's half of a sphere. Once we figure that out, then we have to add the two total surface areas. All right, sorry, we have to add the two areas to give us the total surface area. All right, so that's what we have to do with this one. And so for this one, we're going to be using a lot of formulas because we need to first figure out what is the formula for the surface area of a cylinder, and then we need to figure out what is the formula for the surface area of a sphere. Okay, so this question is asking us for the total surface area. All right, so in order to figure out the total surface area, what we need to do is we first need to figure out what is the surface area. So surface area of the cylinder, that's important. So we need to determine what is the surface area of the cylinder. So we need to figure that formula. So the formula is going to be, so formula for surface area of a cylinder, right? Okay, so this is the formula that we are given for the surface area of the cylinder. It is 2 pi RH plus 2 pi R squared. Alright, so that's the formula for the surface area of a cylinder. 2 pi RH plus 2 pi R squared. Yeah, 2 pi RH plus 2 pi R squared. Okay, good. Okay, so let's keep that formula because that's going to be helpful for us when finding the surface area for the cylinder. So we need to use that formula. So this is the formula right there. I'm going to put it on the side. So the surface area of the cylinder is going to be equal to 2 pi r h plus pi r squared. Now remember what these things mean. First of all, what is pi in this question? Where did they tell us that pi was?
22/7.
They told us that pi was 22/7. Very good. And how do we know that? It's because if you look at the question, let's go back. Let's go to the initial question. They said using pi equals to 22/7. Okay, so pi is 22/7 in this question. Let me go back again to show you. Again, if we go to the question, this will be right here. They said using pi equals to 22/7. All right, so that's important. So pi is 22/7, and that's going to be that's what we're gonna be using for pi, 22/7. Okay, so that's important. So someone is asking to join. Okay, good. So pi is 22/7. So let's make a note of that. Good. So here pi is 22/7. So let me use pi. So pi is equal to 22/7. Good. That's the first thing. Next thing is what else we need to know. What is R? So pi is 22/7. What is R? We saw R yesterday. R is what?
2.1 meters.
R is in terms of words is what? So we call what is R in terms of words?
Radius.
That's the radius, very good. And the radius is half of the diameter. So the diameter here is 4.2, right? The diameter of the circle is 4.2. That's the length of the circle from end to end, right? So the diameter is 4.2, but the radius is always half the diameter. So it's going to be 4.2 meters divided by what?
2.
Divided by 2, as we saw yesterday, right? Divided by, where's the division symbol? Maybe, let me just use this. Divided by. Okay, so divided by. So, and 4.2 meters divided by 2, we saw was what?
2.1 meters.
2.1. 2.1 meters. Good. So the radius is 2.1 meters. Now we need H. H is what?
17.5 meters.
Good, because H is what? In terms of words, H is the height.
Height.
Height. And the height of the cylinder is 17.5. Okay, 17.5 meters. Okay, so the height of this is 17.5 meters. And so that's going to be 17.5 meters. That's the height. Good. Alright, so the radius is 2.1 meters. The height is 17.5 meters. And so we're good to go. So let's calculate this now. So it's going to be equal to the surface area It's going to be equal to, I think someone is asking me something. Keisha, right? So the surface area is going to be equal to, insert 2, right? Because 2 is a part of the formula, multiplied by pi. But we know in this case pi is equal to 22 over 7, close bracket. Let me increase this a bit. Let me make it bigger. So we have 2 pi, which is 22 over 7, r, which is
2.1
1 meters, h, which is
17.5
17.5 meters, plus what? 2 again, right? Times pi. Pi is
22 over 7.
22 over 7. Multiplied by r squared. R is 2.1
meters squared.
squared. Oh my goodness. 2.1 meters squared. Good. And so what we need to do now is we need to multiply them all out, right? We need to multiply it all out. So the surface area, look at this, the surface area is going to be equal to 2 times pi times r times h plus 2 times pi times r squared, which is 2.1 meters squared. Now we need to multiply them all out and add them. And so what would the answer be when we multiply them out and add them? So let's put it into our calculator.
Or you could do it by hand.
You're a funny girl, you know. Cooper.
Am I being serious?
Right after you. Okay? Right after you, we can do it. 22 over 7. Have these interesting. 22 over 7 times 2.1 times 17.5 plus 2 times 22 over 7 times 2.1 squared. 2.1 squared. Good. So we have 2 times 22 over 7 times 2.1 times 17.5 plus 2 times 22 over 7 times 2.1 squared. All right. And so that's going to be equal to, let's see, 258.72. 258.72. Did anyone else get that too? 258.72. 258.72. 258.72. Now this is going to be meters, meters squared, meters cubed, meters what?
Square.
Say it again.
Square.
Squared. Why you say meter squared?
No.
You don't know? Anyone? What's going to be meters squared, meters cubed, meters to the fourth, meters to the fifth? What is going to be?
Meter square.
Meter square.
Squared. Why you say meters squared?
Because when you
Like only 3
when
meters.
you multiply m and m on the first set and I don't know. You multiply m and m on the first equation and you did it, and then the 2.1 was already just squared. So and then when you bring it down, because you're adding it,
Yes.
it stays the same. So it's
Very
m
good.
squared.
Good. So m times m is meters squared. And we don't say meters to the fourth when we do it like this because we are adding them right there. Okay. So m and m is meters squared plus this other thing that is meters squared. So everything would be meters squared. Another hint that you would easily know. Okay, so m and m is meters squared, right? So that means that this side is meters squared and this side is also meters squared. You understand now?
Yeah.
So m and m makes it meters squared because we're multiplying them. So you add the powers. So this is to the power of 1, this is to the power of 1. This m is to the power of 1, this m is to the power of 1. And when you multiply them, since they have the same base, you add the power. So it's going to be m and m, which is meters squared. So this side is meters squared. This side is also meters squared because it's m to the power of 2. Now, since we are adding these two quantities, this quantity and this quantity, we will keep the power the same. So it's still m to the power of 2. And that's an easier way to know it. Like if you're dealing with area, it's meters, it's units squared. If you're dealing with volume, it's units to the third power. So that's an easy way to know it. Like area, anything with area is units squared. Anything with volume is units cubed. Okay, so that's how you remember it too. All right, so the correct answer here for the surface area of the cylinder is 258.72 meters squared. Now, are we done?
No.
No, because all we know is the surface area of this cylinder, right? All we know is the surface area of, where are we? All we know is the surface area of this cylinder. Okay, that's all we have done, the surface area of this cylinder. What we need is we need the surface area of the entire object, which is including this this sphere. So we need to figure out what is the surface area of this hemisphere. Okay, so let's figure out what is volume. Sorry, what is the surface area of the hemisphere.
Still didn't do it by hand.
Yeah, we still didn't do it by hand. This isn't a by hand question. You'll be all night. Where are we now? Yeah, so we need surface area of hemisphere. Formula. I'm trying to find the formula for the surface area. Okay. 2 pi r squared. That doesn't make sense. 2 pi r squared is area of a circle. Okay. That's interesting. Let's see. Surface area of a hemisphere. Let's see. Okay, the total surface area of a hemisphere is 3 pi r squared. Right now, that's what they tell us. So 3 pi r squared. So that's the formula we're going to use for surface area of a hemisphere. 3 pi r squared. Okay. So surface area of the hemisphere equals what? Equals what?
3 pi r squared.
3 pi r squared. 3 pi r squared. Three pi r squared. That's what they said? Yeah, 3 pi r squared. And again, 3 pi r squared. So the surface area of hemisphere is 3 pi r squared. We already know that our pi is 22 over
Well,
7.
they don't have that on the paper itself.
Not for hemisphere. They may have it for they may have it for let's see, they may have it for sphere, but not for hemisphere. Okay, so where we go? Yeah, so they have it for surface area of a surface, Speaking of the sphere, right? They have the volume of it, and they have the area of the surface, but they don't have it for, this is 4 pi r squared, but they don't have it for a hemisphere. So the hemisphere one, you just have to know. Or be able to derive it from the main one. So the surface area of the hemisphere is going to be 3 times, well, we know pi is 22 over 7, as we saw, 22 over 7 multiplied by r squared, and r is simply 2.1 meters. Okay, and so surface area of hemisphere is going to be 3 times 22 over 7 times 2.1, where pi is 22 over 7 and r is 2.1 meters. So all in all, the surface area of the hemisphere, let me put this on this side. All in all, the surface area of the hemisphere is going to be equal to, here leave the multiply these 3 terms here. The 3 multiplied by the 22 over 7 multiplied by the radius squared. And so let's multiply them together. So on your calculator, you have to put 3 times 22/7 times what? 2.1.
1 force. 2.1 meters squared.
Yeah, 2.1 meters squared. So 3 times 22/7 times 2.1 squared. It's going to be 41.58. So again, 3 times 22/7 times 2.1 squared is 41.58. .58 meters squared. Good. So that is surface area of the hemisphere. So let's put that in baby blue. So we know what is the surface area of the hemisphere, and we know what is the surface area of the cylinder. And so the question is now, seeing that we know both of them, what are we going to do to figure out what is the total surface area?
Add them.
Yes, we have to add them. We have to add them. So it's going to be, so now we want the total surface area of the silo. It's going to be equal to it's going to be equal to 2.58.72 meters squared plus 41.58 meters squared. So adding them together, what do we get?
300.3. Right?
Say it again. I get barely hear you.
300.3 squared.
Okay. Who's that speaking?
Rafika.
Oh, Lakeisha. It's been a while.
Yes, sir. It's been rough.
Okay. 2.58.72 plus 41.58.
300.3 meters squared.
Yes, 300.3 meters squared. That's what you said, Miss Lakeisha?
Yes, 30. Yeah.
Okay, good.
300.3 squared.
Okay. Okay, good. The total surface area of the silo is going to be the sum of them. Okay. Any questions on this?
How much points does a question like this is worth?
How much points do you think?
10?
Say it again? Say 10. Well, I can let them tell you. They say this is worth, according to them, they'll give you 5 points for doing that question. So 5 points for the total surface area, and 5 points for the volume.
That's paper 3, right?
Yeah, that's paper 3.
Or no?
Yeah, that's paper 3. But for paper 3, this is easy though. What do you think?
Yeah, just keep practicing it. Ooh, something like that.
Yeah, just keep practicing. Pretty straightforward question. I mean, no, the hardest part of this is the formula. Because if you don't know the formula, I'll get you lunch, breakfast, and dinner. Ain't nothing you could do. So, know the formula. That's gonna be
But they have the formula for the safest area, the safest area of the cylinder, but not the safest area of the hemisphere,
no,
right?
no, yes. So those are stuff you'll have to memorize. And that's the trick, you know. They'll say, oh yeah, we give you the formulas, but they give you a formula for the wrong things. So, don't be fooled by them. No, the formula is not only for the whole um entity, but also for half of it, a quarter of it, and stuff like that. All right. Okay, so let's move on. Number 3. This is the last question, I think. It's the last question on this paper 2, Bgcse paper that we're doing, 2016. The last question, number 3. Should be pretty straightforward. And it says 6 pence costs $2.40. Calculate the cost of 1 pen. So how would we do that? We know that 6 pence costs $2.40. What would be the cost for 1 pen?
Divided by 6.
Divided by 6. Very good. Now, for that question that we just did, please send the work in for it. Thank you, Miss Lakeisha. But for the rest of you, please send the work in for it. Okay, so yeah, so we need to divide 2.4 or 2,040 cents, thank you, Juan, by 6. So it's going to be 6 divided by, or sorry, 2.40 divided by 6. And so, you know, we ask ourselves, how much times can 6 go into 2? 6 goes into 2. 6 goes into 2, how much times?
3 times.
5.
What? 6
3
goes into 2?
times.
6 goes into 2?
Oh,
0.
0 times.
yeah.
Oh,
Yeah.
wow. Okay. So we really need to start back from primary school then.
I was
What do you
thinking,
mean how much times? Oh, you mean I talking about 200? Sorry, I thought you mean dollars. Sorry.
Now, how much times 6 goes into 2? Oh, you mean dollar? No, that still wouldn't be right though. Oh, but I guess you mean 6
Like
pennies.
according to the question. Yeah, I did thought
Okay.
according to the question.
Okay. All right, class, what is 1 plus 1? And make sure we still.
2,
So,
Okay, good. That'll
2,
start. That load M.
8.
8? Oh, wow. We need to start from the beginning.
All jokes, I mean that.
6 times 0 is 0. Kennedy, you kill me, you know. 2 minus 0 is 2. We bring up the point and we bring down the 4. How much times 6 goes into 24?
4.
4 times. Very good. 6 times 4 is 24. Miss Cooper, you happy? We doing this by hand. I know you in your glory now.
She ecstatic.
She ecstatic, exactly. She's so happy she's speechless. 4 minus 4 is 0. 2 minus 2 is 0. We bring down the 0. How much times 6 goes into 0? 0 times. 6 times 0 is 0, and so 0 minus 0 is definitely 0. And so the cost of 1 pen is 40 cents. Are we good?
Yes, sir.
All right. So the cost of 1 pen is 40 cents.
That's them type of pens that run out of ink when you write one word.
When you write one word. No lie. That's them said where when you try to test it, you squatching all day.
Yes.
Yeah. Oh my. 40 cents.
40 cents for pen.
Yeah, 40 cents. That's back in
One of my pen what I buy cost $3.
$3? Where you buy that from, miss? Wow.
That electric
I
penny.
know, right? That pen is
Yeah,
right.
electric pen, but it have pen ink in it.
It is right for you, eh? It
That's
is
how I
right.
get my blasting pen.
No, I wish it would.
That pen is right for you, eh? Ah. Okay, so we want the cost of 9 pence. So how are we gonna do that? The 1 pen cost was 40 cents. Was the cost of 9 pence.
The 40 cents times 9.
So 40 cents times 9.
Right. So cost of 9 pence. Anyone got an answer yet? 0.4 times 9.
$3.60.
$3.60.
$3.60. Okay. It's gonna be $3.60. So we do is multiply it. And the reason why we multiply is because another way we could do it, we could add 0.49 times. But we know that multiplication is repeated addition. And so if we add in something 9 times, it's the same thing as multiplying it by 9. Oh, righty. Good stuff. Okay, so let's go back to our question here. A small scale model of silo is made on a scale of 1 to 20. Calculate the total surface area of the model. 1 to 20. The total surface area of the model. 1 1 to 20. That's only for 2 points. Oh, I don't know how to do that one. I don't know how to do this. C, I don't know. Any ideas on C? Small scale model of seal is made. We know the surface area of the big one, of the full size. And if we know that a model is made, it's 1 to 2, it's 1 to 20. Calculate the total surface area of that model. 1 to 20. I wonder what the 1 to 20 means. Unless I don't get any guesses or anyone? Why are you so quiet? Huh?
See, what do you mean by scale from 1 to 20? Because it's a small scale model, meaning that's like what? It's smaller than the one we have on the up there on the model.
Yeah, it's smaller.
So what do you mean by 1 to 20? Like
That's a ratio.
the entire thing is equal to a 1 scale model, or like a 1 scale model is equal to 20 times?
That's what I'm trying to say. Maybe it's what? 1 to 20. 1 to 20.
Because remember, we're trying to make them equal, so
1 to 20. 1 to 20. 1 to 20. Maybe it'd be 1 to 20.
like divide, whereas you divide divide it by 20, and then you'll get the one small scale because they're asking for the small scale, not the big one. So would you just?
So I guess they're trying to say. I guess they're trying to say that. I guess they're trying to say that it's 20 times. The scale model is 20 times smaller than the big one. That's my guess. I'm not sure on it, but when we come back to this question, I hope to be sure. But now that you say that, I guess it means that if it's a 1 to 20, I guess it means that the scale model is 20 times smaller, which means that the real thing is 20 times bigger. And so if that's the case, then I guess we'll divide this by 20. The surface area. That's ideal, but I'm not sure. It's a good question. All right, this was a good one. I ain't sure about this one, honestly. Okay, so let's go to the next question. This was what, 11? So we did the functions question. We did all of it. Oh, why did we skip this?
Oh, this is paper 3, right?
Yeah, all of paper 3. Why did we see? We did the functions, and we did the surface area. We might as well do the graph then. What do you say?
I thought we was going up. We going down?
No, the thing is, no, we skipped the. We supposed to start from the graph to go up. You see?
Oh.
Yeah.
Okay.
Yeah, we supposed to start from that. So that's I guess I was avoiding the graph because it would take long. But since we have about an hour left, I think we could do a graph. By the way, what type of function is this?
Here. Quadratic.
Quadratic. Why is it quadratic?
Just the power to 2.
Highest power is 2. Highest power is 2. Very good. Wow, y'all getting smart. I wonder who's your teacher.
I really wonder.
So one issue that we just can't add then. It's only when we can add you disown us.
Yeah, when you can't add, I know it's teacher. I know who taught you. Ah, boy. What they say, for better or for worse? In sickness.
For richer and for power.
Yeah, for power. My goodness. Wow.
No, I do not consent.
Fancy thing he did. All right. Okay. So copy and complete the following table for the graph of y equals to 30x minus y minus x squared. So this is a quadratic function, right? Quadratic function. We know that because the highest power of x is 2. It's a quadratic function. Now, one thing about quadratic functions is that their graph, right, is the shape of a
AU.
how you know that? Wow, very good.
I remember
Just
you.
told us that the other day.
Okay, all right. Okay, good. Wow.
You didn't think we that bad, Mr. Petit? Wow.
Wow. I was surprised if y'all remember anything because it's be hard some days. Some days it'll be like, all right, and I thought that, and I thought that. So it's U. So it's either gonna be a regular U. This is when um this is when this is when the I'm tell you when it's up when it's a regular U when it's like this. That's when x squared, the coefficient of x squared is positive. But here the coefficient of x squared is negative, so we expect it to be upside down U. So when the coefficient of x squared is positive, it's a upright U. But when the coefficient here is negative, it's upside down U. So we expect it to look something like this. Okay. Um okay, so how do we figure out what is the value of this guy? And how do we figure what is the value of this one?
Everywhere you see X, you would replace it with the variable on top.
Very good. So just substitution, right? So tell me what is it for 5 and what is it for 15 as I do it out. So x equals to 5. And so x equals to 5. So we're going to use this function. So it's y is equal to, so please draw this graph. Sorry, please draw this table and do the working that I have. So it's going to be 30. Remember, x is what? 5.
5.
Okay, 5 minus, remember, x is
5.
5.
5.
It's going to be 5 squared. And for the people who like doing working by hand, this is for you. 30 times 5 is what?
150.
Say it again.
150.
150. With your eyes closed, A. Kennedy.
With my eyes closed, indeed.
5 squared is what?
25. Wow.
5. Good. And so what is 150 minus 5?
125.
1 what?
25.
125. All right. Lionel back there for you, boy.
No,
Lionel?
I was reading. I back now. I fully back.
Oh, you fully back. Okay, all right, good. Lionel try to make up before health science and general science questions. So y'all can trust me.
Yeah, I got all right.
I can stay asleep.
You got 100 and what?
Said we got 100.
Okay.
Who's we?
You mean the last time that we were here.
Oh.
So
There was one class.
so x is equal to 15 in this case. What do y'all get for x when x is 15? Anyone did it?
Doing.
Doing it. So y is equal to, so we're still using the same formula, this quadratic equation that they give us. So it's gonna be 30x. Excuse me, 30x. Oh my goodness, x is 15, so we have to replace that. It's gonna be 30 times 15.
I get 225.
225 minus,
Yeah.
okay, minus 15 squared. And so y is gonna be equal to, what is 30 times 15?
450.
450. 30 times 15 is 450, yes. 450 minus, what is 15 squared?
225. 20.
That's 15 times 15, which is 225. And so y is going to be equal to 450 minus 225,
225.
which is simply 225. Okay, so it's going to be 225. This is 225. All right, so now we've completed the table. Any questions on how we got those values?
Come over, Mr. Badi.
All right, so keep it there for a while. All right.
Mr. Petit,
Go ahead.
I'm looking at the numbers, right? We have to go, okay, I might the graph can look difficult then because these numbers high.
Yeah, I thought about that too. I thought about that too. We have
Because
to.
I'm trying to do it, I get
I have it.
it, but I don't know if I can do it depending
Yeah,
on the number.
yeah, it
I
depends.
wanted to try out the graph, but I don't think we can, eh?
We can. We just have to be careful. Um, we have to see how they say what they say to count in. So they might tell us to count in certain numbers. So let's see how they what they tell us. Remember, this is paper 3. This is not paper 2.
Can you go back, please?
So that means that the graph is going to be it's going to be a little more interesting than the regular. All right. So just be prepared for that. Okay.
Thank you.
No problem. So this is extended. So they're saying that we should have extended brains, I guess. Or extended, extended imagination or whatever, or foresight. See, look. So now it's reading something different. So it's saying using a scale of what? 2 centimeters to what? 5 units.
5 units.
Yeah. So that means that,
Mr. Badi,
yes, sir.
can you explain 5 units, please? What do you mean by that?
Yeah. So they're saying, yeah. I was just about to explain it. What they mean is that every 2 centimeters is 5 units. So you count in fives, right? But every 2 blocks is 5 units. All right. But that's for the x-axis. And for the y-axis, every 2 centimeters is 50 units. Right? So that would make sense. So 2 to 5 and 2 to 50. And so x is going to be from 0 to 40. And that makes sense because x only goes from 0 to 30. Right here, the highest x value is 30. And then y goes from 0 to 300. Okay, so using that scale, we're going to do that. Remember that for the x, we're counting in fives, and for the y, we're counting in 50s. You see that? So using a scale of 2 centimeters to 5 units on the x-axis. So we count in fives for the x-axis, and for the y-axis, we're counting in 50s. Okay? All right, so, okay, so let's go. So let's get that.
I didn't like the question.
Oh, you need to write that on that question? Okay. Okay, Watsi, is there any other questions on?
Okay, I'm confused by. I understand what you just said, but I can't picture it on a graph though.
You can picture it on the graph, it ain't that deep. Watch, when we do it, you will see.
40?
Yeah, from
Okay.
0 to 40, you see?
So this thing fit in my book then.
It should fit in your book.
Oh, I just say you do it first. I can see.
You can see, okay, no problem. No problemo. Boy, I see why this is paper 3, boy. They trying to be slick.
Mr. Badi,
Yes, sir.
go back on the question, please.
Still not finished.
Okay, no problem. Let me see this. Oh, look at that graph paper. Silly, right? I guess it's because of the way it's printed. So not printed, but the way it's so I'm using the word it's the way it's scanned.
So, what's sort of like people taking paper 3 Mr. Petite in school?
What's the rate?
Yeah.
A lot of us didn't do it, you know. A lot of us didn't do
I
it.
mean, now during the pandemic, like a lot of people actually sit the exam, or we just the weird ones that sit in this exam. Because you encourage us to sit it, so I'm just,
Well, I would say
trying
this.
to figure it out.
I'd say this that you all getting a lot of practice, you know. In my opinion, you all getting way more practice than I had when I was a student. We never had this much amount of practice, never. Because of the internet and because of online school, like you all getting a lot of practice. And like with us, the most practice we had was, I can be honest with you, the most practice we had was after school with afternoon classes, and that only lasted an hour or two, and that wasn't every day. And so when I went into the Bgcse exam, a lot of those things I wasn't familiar with. I ain't gonna lie, like um like we just did not enough practice. But the good thing is that our teacher was good in teaching us the general concepts, so I was able to apply it, you know. But you all getting a lot of good practice in. You seeing the papers, that's the good thing, and you seeing the questions that come on it, and you're getting a lot of hours in, and so that's a good thing. And as far as y'all being the weird ones, a lot of people are gonna sign. A lot of people sign up for the extended. In our school, few really, few, few. I ain't few who sign up. Few sign. I can count them on one hand. Yeah, I count them on one
I
hand.
have a question. Would
Yeah.
this add take away from the exam? Like, would it add to it, or would it take away? Like, if you fail this paper, or
Okay,
if
if you
you
fail
pass this?
this, if you fail, okay, that's how it goes. Um, Extended only could add. It could never take away, right? So, what I mean is that if you do not, in order for them to even consider your third paper, you have to do a certain amount in the core first before they even could consider your extended. Right? So if you do jokey on the core, they ain't even can consider the extended. Um, but if they do consider the extended, the extended will help to let you get the B or the A, right? Without extended, the highest you can get is a C. And that's if you get,
Okay.
yes, ma'am.
So now, sorry to interrupt. I want you to finish. Sorry.
Yeah, without extended, the highest you can get is a C. And that's if you get 100% um, on um, on paper 1 and 2.
So my question is right.
Mhm.
If you fail paper two, then you may go look at your paper three.
If you fail paper 2,
Yeah, they want to look at your paper three.
you failed 1 and 2. Yeah, if you failed 1 and 2, ain't an option for paper 3.
Like even like if you got low scores on both of the papers, they won't even consider
No,
marking.
no, they wouldn't even consider paper 3.
So that's basically a waste of time for the student. Then
No, it isn't. I mean, if you so good that you sign up for paper 3, like you have to be saying something for them to even to consider paper 3. So that's the thing. So, but all of you all here should do well, provided that you don't sleep in class. Um, sorry, excuse me. Provided that you don't sleep in class. Um, uh, and you stay awake. And
I
you
thought
hope.
you said it was getting blind this week.
Pardon?
I thought I was off the hook this week.
I never said. I never mentioned anyone name. I didn't mention anyone name. What happened? Are you
You tell me that personally. Like, come on, man.
are you are you
You forgot the entire conversation.
are you guilty of something? I just say provided that you don't sleep in class. I ain't
Okay.
calling names.
All right. That's enough. Thank you.
Oh, wow. Okay, this is good stuff. I'm looking for a graph. Will this be good enough? Yeah, let's hope that this is good enough. Okay, let's see. I don't know. I don't know. That's okay. What we gotta do is we have to find a sensible graph. Okay, so this is Bgcse 2019 March pretty.
What you don't know?
I trying to find a I gotta graph the function, but the graph that they have doesn't look good. So I trying to find a good one. I don't even like this one either. I think 2016 one is nice. Let's see. Yeah, this is good, right? It's better than the rest, in my opinion.
Is she? Oh,
All right. Okay, so let's get this graph going. Okay, I'm hoping at least that it's enough. Okay, so all right, so there we go. So the first thing we need to do is I'm just gonna check and see before I even do anything. We need to check and see if it will work for the size that we're looking for. So we know that we need, let's go back to our question. We know that they say we go up from 0 to 300. So we're going from 0 to 300 and we're going in 50s. Okay, this is going to be interesting, boy. It's going to be 50. It's going to be 100. This is going to be 150, 200, 250, 300. Okay, good. We have enough. Okay, yeah, good. We have enough. Very good. All right, so the first thing we need to do here is we need to draw in our x and y axis. So let's draw in our y axis here. Right there. Good. So let's we're gonna put that in red just so that it could be seen properly by everyone. So okay, let's do that. So something like that. Good. So this is our y-axis. Good. Next thing we have is our x-axis. Good. Right there. So we have our x. Say it again.
How much it costs?
How much across? We're gonna determine it right now. Okay, so let's see. Slideshow. Okay, good, 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 good. I want to make this a little bit. I'm gonna reach up a little bit, some more. Good. Just so I have some space at the bottom to right, and then so let's need to put this. We need to increase this and put this some more. Very good, like that. Okay, good. So I think we're ready. All right, so good. So wait, let's increase this some more. Put this up a little bit more. Good. All right. Okay, good. So everything is good. So what we did, all we did was we draw in our y-axis and then we draw in our x-axis. And so let's label it. So this is going to be here. This is going to be our y-axis. Please label your axes, please, people. Y-axis, and this is going to be your x-axis. Label your axes. That's the first thing. The second thing is that we need to put 0 here. Alright, that's the origin for us. And remember, they say 2 units. So we deal with the x-axis, and that's the their command. They said, hey, 2 centimeters to 5 units. So 2 centimeters to 5 units. So that means we're going to be skipping 2 blocks. Then we get the 5 units. So every 2 blocks is 5 units. Every 2 blocks is 5 units. So that means that we're going to go, so this 1, 2, and then we have the stop at what number? 40. So we need to go from 0 to 40. And every 2 blocks is 5 centimeters. So it's going to be right here. Maybe I should use a block. Alright, so this is 5 units. This is 5. What should I put here?
10.
10, very good. And then this one is 15.
15.
Right. Then this one is, oopsies,
20.
20. Then this one is
25.
25. Let me make sure that these are better looking. So this is, again, this is 20. This is 25. Goodness. This is, so we skip 2 blocks. This is gonna be
30.
30. And then it's 30, 30. I'm sorry, it's just interesting to be writing so small. So 30. this is going to be
35.
35. And this is going to be
40.
40. Good. So again, every 2 units is 5. Every 2 centimeters is 5 units. And now this one we counting in 50s. So it's going to be 50. Remember, they say we going from 0 to 40. So we can't go higher than 40. Leave it at 40. So 50, 0 to, it's going to be
100.
50, 100. Yes. It's going to be 150. It's going to be
200.
200. This is going to be 250. And this is going to be 300.
300.
So again, we move on the y-axis from 0 to 300, from 0 to 300, and then on the x-axis we move from 0 to 40. Now, it's not every time we have to draw the graph like this. Now, only sometimes. You notice that in some of our questions we had where the graph looked like this. Remember? And you remember where this is y and this is x. Remember when we did it like that? So the question is, why did I only use this side? And I didn't do it like this.
Don't have negatives.
Exactly. Because if you look carefully at my numbers, excuse me, I don't have no negative number. Right? So I don't know negative numbers. So since I don't know negative numbers, there's no need for me to include negative numbers. So I don't have to do it like the cross way. I could do it just like this because I only doing positives. And if I did include negative numbers, I wouldn't have enough space. All right. And so this is how the orientation of the graph should look. So we almost there. All we did was we do our y-axis to y-axis, label it properly. The next thing we need to do is we need to plot the points, right? So we need to plot the points. So let's go and state what point, the first point that we're gonna plot, and then start plotting. So
Go to that graph, please.
no problemo. Our first point that we're gonna plot is the point 0, 0. Now that's the origin. So 0, 0. That's right there. That's the point 0, 0. That one is at the origin. The next point that we're gonna plot is the point 5. Sorry. Is the point 5, 125.
8 o'clock rolling around pretty fastly.
8 o'clock? What time is it?
I say rolling around pretty fastly.
Yeah. Yeah, that's how it always happens when you. All it takes is one Bgcse paper question, and then I'll say only one. 5 and 125. So 5 and 125, 125. So again, 5 and 125. So if this is 100 and this is 150, where's 125?
Right below it.
Say it again. It should be what? Halfway, right?
Okay.
Half of it, yeah. So 125 should be right up. So because this is 5, this is... Sorry, because this is 100, this is 125, this is 150. Okay, good. The next thing is... Then we have 10, 10, 20. Sorry, 10, 200, excuse me. 10, 200. So 10, 200. What's this point right now? 10, 200. So 10 on the x-axis and 200 on the y-axis. Next thing we have is 15 and 225. So 15 and 225. So that's 15 and 225. So 225 is right here. Good. So again, that's 15 and 225. Next up is 20 and 200. 20 and 200. So that's gonna be 20 and 200. So 200 is right here. 20 and 200. Good. Next up we have 25 and 125. So 25 and 125. Again, 25 and 125. So it's gonna be 25 and 125. 25 and 125. So this is right now. You come back again.
Then
And 125.
30.
Say it again.
The last one is 30 and 0.
The last one is 30 and 0. Okay, so 30 and 0. 30 and 0. But wasn't we expecting that shape, right? Because we said that because this is negative, it's gonna look like what, an upside down U. Didn't we say that?
Yes, sir.
Yeah, so it's important to know orientation too before you even graph the thing. That'll give you a good idea of what's happening. So 30, 0 is gonna be right up. All right, so we are ready to draw this curve. The scariest part, in my opinion. Oh boy, how will this curve look? Okay, so I want to draw it properly. So and we want our stuff to pass through the points properly. So okay, so it's supposed to be like a smooth thing. Man, this is always the interesting part. So let's go. Confidence, let's go. So we're gonna graph it up. All right. Nope, that's missed. So let's do it again. I guess the best way to hit it is from the vertex, or hit it. Anyway, let's draw the arc properly. So it's gonna be from here. Let's try and follow the points. Okay, this is not steep enough, so I need to hit it more steep. All right, so this is okay. So good. much better. So that hit that point. Get that point. At that point. Oh my goodness, that mess. That and that. Okay. Oh my, that's terrible. Okay, but close enough. The idea is that it should be looking like this. It should be one line, one
See, it's supposed to be straight.
not straight, not no, not no, it's not supposed to be straight. Now, please do not draw no rule, use no ruler, right? It's
Mr.
supposed to be
Petit,
yes, sir.
why go the fault point on 275
275, 275. Which one?
between 250 and 300?
What is supposed to be on?
225.
You sure?
Yeah.
15 and oh, that's why it's giving me a problem. Thank you. That's why it's giving me a problem. 225. 15 and 225. So that's 225 should be right here. Okay, that look better. Alright, that's much better. And so I think the curve should look better now.
Mine's just on 225. I wonder why yours so sticky.
Yeah. Okay, so there we go.
I thought it was because our graph kind of different.
There we go. There we go. And then the next one is going to go this way. There we go. There we go. And there we go. All right. That look way much better. Okay, so we understand the orientation, right? So this is gonna be the graph y is equal to what? 30x 30x minus x squared. All right. Okay, are we good?
Yes, sir.
All right. Okay. All right. How many percent graph come out looking sensible?
Thanks. My bad.
Say it again.
Mine. Yeah, good.
It's okay. Well, show me proof. Proof. The proof is in the pudding.
Okay.
The proof is in the pudding. And for the rest of you, send me the photos as well. All right. All right, send them for me, please. Thank you, Mr. Keisha. Thank you.
What other subject we having today?
We have in general science and health science.
Okay.
Very good, Mr. One. Thank you, Mr. Okay, your graph's supposed to look like it's supposed to be look like one smooth curve, right? Like this. It's supposed to have a symmetricness to it, right? A symmetry to it. It shouldn't look like this. It shouldn't look like a paralyzed U. It shouldn't look like this, right? It should be nice and smooth.
My graph got only the one from the first, second point with that line right there.
Thank you. Yeah, very good. What's his name? Very good, Ricardo. Ricardo, why don't you label your X and Y axis? Oh, I see it. Okay, it's labeled. I see it. Okay, yeah, pretty decent. Good stuff.
Mr. Bgcse,
What's wrong?
what am I doing wrong? Why am I so like a V?
That's what I'm saying. It looked like it looks sticky.
I don't know what I'm doing wrong. That's the points, right? 50.
Remember, you free-handed, so it wouldn't be as perfect. So
Oh.
yeah.
So they would mark you down if it like in like a smooth curve too.
Yeah, your graph need to be a smooth curve, right? So, but it would be if it would be because you would be using graph paper.
Using pencil.
Yeah, use pencil. Pencil. Don't do nothing on the graph. Only the numberings could be in pen, but for the graph, the numberings and the labeling of this, but everything else, please in pencil. I would even, you know what? Just do everything in pencil. Don't put nothing in pen, unless something is light and you want to darken it, like say the labeling of this. But everything else in pencil.
So what if you want to trace over what you draw? Like you could use a pen.
No, pencil, pencil.
Mr. T, how you get 125 again?
125.
Hey, Mr. D.
You mean now?
Yeah. No, I mean on the graph. How you get that on the graph?
125. Oh, how I get 125? So this is 100, right?
Yeah. Yeah.
So, and this is 150. So half of in between 150. Sorry, where's this line? In between 150. In between 100 and 150, directly in between is 125. Right, that's halfway. So that's how I got the 125.
In exam, we have to trace it with pen or pencil.
Don't trace nothing.
I mean, I draw that.
Draw it in pencil. Draw everything in pencil. The only thing that you might get away with writing in pen would be the labeling of your of your graph, but everything else in pencil. Nancy, you actually draw a whole graph paper. Wow, that's amazing.
Me too. I can't find my graph book.
Wow. All right, so let's continue. Okay, so yeah, so I think we have time for one more question or two. Okay, so let's see. So with this paper, right? The next thing we need to do is we need to do C, solve the equation. We're not gonna do it today. We can do it tomorrow, and then find the gradient. All right. So that's the two questions that's outstanding. All right. So we might as well do that, because we finished this paper. We finished paper 2. So let's just see if we could finish up at least C. Use your graph to solve the equation x squared minus 30x plus 100 equals to 0. Hmm. 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 Use your graph to solve the equation x squared minus 30x plus 100 equals 0. So they want us to use this guy to solve this.
That sounds so technical.
Yeah, I'm trying to figure out how we do that. Like, they ain't even. I'm trying to figure out what is the similarity between the two. What really have me thinking is that this is not even, use your graph to solve the equation for x squared minus 30x plus 100. Unless somehow we could, I don't know how to use the graph to do it, because
So do they mean like the bottom graph, like when the numbers could be squared to then like they're actually the numbers or no?
like, okay, they saying that we have to use this graph, so 0 0 and so the zeros, okay, the zeros of this, okay, what this is saying, right, is that, okay, what we know from this, I can tell you what we know from this, right? And maybe that's what they understood. Like, what we know from this is that, all right, so what we know, right, from this is that, what we know from this, from the graph, right? I tell you the information that we do know from this is that, so we have y equals to 30x minus x squared, right? That's what we know. And we know that if y is 0 in this case, right, the value of y, sorry, when y is 0 in this case, right? So let's say that y is 0. Y is 0 whenever this graph touches the x-axis. So y is 0 here, because here this is the point 0 0, so y is 0 here. Y is also 0 here. So that means that so y is 0 here and y is 0 here. That means that the value of x, right, the value of x that would make this equation true is x is equal to 0 and x is equal to 30. All right. Now, that is true only when, so this is true only when x is 0 and when x is 30. We know that this is going to be true. We know that this is going to be true. And so that's what we could deduce from this graph. Now, they give us another equation, which is which is x squared minus 30x plus 100. And so what we basically have now is, so that, let's see, we have y is equal to x squared minus 30x plus 100. All right, that's what we have. But what we had, that's what they give us. But what we had was y is equal to x squared minus 30. Sorry, what we had is y is equal to 30x 30x minus x squared. That's all we had. Somehow there's a connection between these two. We know that this is going to be equal to 0 when x is 0 and when x is 30. With this one, if we why? Alright, sure. Okay, we can look at that tomorrow. I ain't sure about that one either. I do know how we could do it without the graph. I do know we could just use the quadratic formula to find this use of the equation. But to use the graph, to use this, I don't know. And so we'll come back to that tomorrow. This one we need to figure. Alright, so we can leave that right there. So with that being said, that brings us to the end of our math session. And I guess for homework you could look at this and see if you find any answers, to see if you could think of anything how we could do it. I can't think of anything using the graph, but I know that we could use a quadratic formula to figure what is the x values that would work for this one. That's the best I could do, unless if we maybe negative 30. I can't say. Yeah, I know how to use the quadratic equation. So I had a quadratic formula to get the zeros for this equation, or to solve it. But to use this graph, I don't know. So maybe you can, look it up and see if you could find a solution for this one. So when we come back tomorrow, you could share it. If not, we're just gonna look at it. We're gonna look back at it tomorrow. And I'm hoping that I'll be able to figure it out by then. All right.
All right.
Okay.
All
right.
Oh my goodness! I did not do. Oh man. Did I take the attendance yet?
No.
No. I don't think I did.
Mr. T, remember how the same thing with biology when you said, I just send you the answers, you send me back the answer sheet?
Yeah.
Can that be done for math as well?
I don't have the answer sheet for math.
Because I was practicing, but ain't nobody in my house who, could mark or have the patience to mark my. Because I want to get more practice to see whether to see if I'm improving.
You mean for bio?
For bio and math, to see where I'm improving. Even with English, I'm beginning to practice more because you said we draw in there to the exam, so more practice.
Yeah.
And I'm practicing, but I have a lot of stuff here. I just need someone to look at it, see
Yeah. I only have the solutions. I only have the complete solutions for bio. I don't have it for math. Yeah.
Any ideas?
Well, I don't know. I don't know. I really don't know. The only thing it say is because you're talking about stuff we haven't done in class yet. Um, the only thing I could say is the only thing I say is try find ways to check your work. So what I mean is there like I like when I do a problem I say okay, this is the way you know how to write. So use the check-in systems that I gave you for the question to know the answers right. So for example, if you got an answer for the equation, right? Like you got the solution is x is 2. So check it by putting 2 back into the equation to see if it works, right? And if it does work, then you know your answer is right without anyone having to tell you it's right. Um, that's what I'd say. Another thing it was also helpful to do is um do questions that you know the answer to. What I mean is um like say for example if you're trying to practice simultaneous equation, um go on YouTube or on online source where they have the answer key. Like remember I was using a site where they had the answers to. So use a site that has the answers so that when you practice and you want the answers, you could just um, revert to their solutions. But if you practice in the Bgcse on your own, those past papers, you would need someone who know the answers or who could, and for further insight. Um, and so that's what I'd say. As for in terms of the help that I could provide, um, the only thing is, say after class, like tonight with me and Juan, we're gonna do something. So maybe after class, um,
Mr. Badi,
yes, sir.
can I join after class?
Yeah, you could join after class too. So like that.
You sure this time, right?
Yeah, I shot this time. I shot this time. I shot this time. Um, yeah, we could do that. Oh, someone send me a PDF. Where you get this from? Try the site. Okay, someone send me. Okay.
Okay. I'm gonna start it just so I'll just do the same for like essay writing as well. Just find ways to improve
Wait.
my practice.
Do we have an essay?
There's a Okay. Okay. Um, this person just sent me a website you could look at. They have the answer key from 2010 to 2020. This is awesome.
Can you forward it to me? That'll be like big help.
Yeah, this is amazing.
Thank you for whoever did it, honestly.
Yeah, this person did a wonderful job. They have biology. In fact, they have biology.
We have chemistry.
No, they don't have chemistry. That's the thing. They don't have
Okay.
chem.
And you have to purchase this like
Yeah, of course, you have to purchase it. But I think it's a deal though.
$19 or $18 for biology past papers.
can you send it to me too, T?
It's a deal, man. It's a deal, man. It's a good 2010. Yeah, man, it's a good deal.
Is it on?
That's plenty
I
money.
did it online shopping. I wish I had it in a book form.
Um, they do have it in a book form, but it's of course it's more expensive now, but not entirely expensive to say like. But this is nice, man. This person did a wonderful job. A wonderful job. Yeah, they did a wonderful job.
I wish they had something for English. Like
Right? Or something.
anything for English.
Yeah. Okay. Alright, so let me forward it to you, Nancy.
Forward it to me too, please.
Joseph and Alicia. But yeah, that's what I'll do.
All right, thank you. Goodbye.
What I could do too. Yeah, because this is what I could do too, because this is useful. What I could do too, I could just buy it, and whatever you're working on, I could send you the photos on if you don't have the money to purchase it. But if you do have the money to purchase it, I would say get it to support the person too, you know?
I have a
Go
like
ahead.
how buying, right? Can I like give you the money? You could like
You
purchase.
can send that to Mr. B,
Yeah,
please.
I
Where I make
noticed that. Can I give you the money so you could
yeah, can I
purchase
give you
it?
some? Then you can like send the link. Like you could pay for it online. Cause I don't know how to do that.
Yeah.
And the money.
Yeah, I could do that. I could do that. Yeah, no problem.
Okay.
Yeah,
Perfect.
yeah, I could do that. Who else? Who else asks for it?
Me as well. I'm willing to jump on that idea as well.
Okay.
You have any BJC ones?
They have BJC. They have BJC. Yes, BJC workbooks would be right up.
One is?
Yeah, general science, health science. Yeah, they even have social studies.
Wow.
You can send the link, please.
Please.
But this is social studies workbook though. This ain't answer key.
I actually don't feel like buying them, so yeah. Wait, is the BJC thing have answers?
This one only these ones are the answers. They have the answers for health and general and math. But for health, general science and math they do. But for social studies it's just the worksheets. It's good material.
So that's for you to work on it then?
Yeah, that's just for you to you don't have to
Mr.
practice.
D,
Yes, sir.
why come BGC more expensive than BGCSE?
I'm trying to figure it out now.
Well, that's a good question.
That's an excellent question.
Pretty, I'm trying to Google it.
I thought BJCSE was higher.
Maybe because it's more in demand. So, yeah, maybe because it's more in demand. This is excellent, man.
$30. That's excellent.
See? It's cheap, man. That's no money. $30. $30.
You said
You know how much food I could buy with that?
for never.
The $30, man. Come on.
I can feed 2 homeless people with that, bro.
But come on, for this information, you know how long you have to do to get these stuff out? It ain't easy, buddy.
I mean, that's 11 years past
That's 11
work,
years
so I
past
guess.
I guess it's worth it. Easily.
Yeah, it's worth it.
Yeah. Alright, so let's get to it. Let's get into it. So the paper okay, by the way, for those who are leaving, have a good night.
Mr. D,
Yes, sir.
Bye.
can I stay maybe in the class and turn the class over, please?
Yeah, you can. You can. Or you could just come back at 9. Doesn't matter.
Okay.
Yeah. Alright, so this is BJC. We doing general science, right? General science pathway.
I'll be back.
No problem. BJC general science. I think this is I think we started 2014. That's what we was on, right? Yes, we was on this one. And Kennedy thought that was what is this again, Kennedy?
You gotta put me on the spotlight. It's
a
concept.
Yeah. Kennedy thought that was animal cell. Alright, so this is General Science. Yes, 2014. All right. Okay, so let's move on. So we did all these questions already. I can't remember where we ended though.
25.
25.
24.
Okay, so I remember doing this one. 25. So we ended at 25, eh? The negative
Yeah.
charge, yeah. And so we're saying that. So what atomic particle has a negative charge? Anyone can remember?
It was D, I think.
The D, the ones on the outside.
D, which
It
is
was,
electrons, right? The ones on the outside, right?
Yes, so.
Yeah. Okay. All right. So D is the ones on the outside. So that's that. All right. So that's the electrons. That's the electrons. All right. So what device protects appliances? So yeah, the electrons carries a negative charge. The protons carry a
Positive charge.
positive charge, and
Neutral charge. Nuance, yeah.
neutrons they carry neutrons carry they're neutral. All right, they're neutral. All right, so number 26. What device protects appliances from electrical overload or electrical surge?
C.
D.
C? No, definitely not.
No, it's D.
B.
It's D. Okay. D.
Yes.
D protects.
What D is again?
The device that protects the appliances from overload is a what? Think of it.
Sir.
I don't know what it.
Breaker? I don't know.
Come on, what device?
Surge detector.
I don't know. Circuit?
Circuit what?
The
Circuit breaker?
Circuit breaker. Yes, circuit breaker.
I mean, I said circuit
breaker.
surge detector.
No, different. All right. Okay, so let's move forward. Number 27.
What happened to A?
Number 27. Which diagram shows what happens to light as it hits a transparent material? The correct answer is A, because
A.
it's transparent. What does that mean?
It goes through. You could see it.
It goes right through, right? So this is transparent, so we get to go the light rays pass straight through. All right. Number 28. Okay, this one is going to be. This one allows. You see that this allows some light to go through. So we call this one. So this is transparent.
Semi-transparent.
No, not semi-transparent. It's not called semi-transparent. What do we call it? Allows some light to go.
Opaque?
Not opaque.
It's trans something, but I can't remember.
Translucent.
translucent.
That's the one.
Translucent. So translucent is
So opaque is C, right?
opaque is C because it allows no light to go through. All right.
So what is D?
D, I don't know what D is saying. D, I don't know. I don't know what that's trying to say. I don't know. In which activity will no work be done?
B.
B.
I mean, it's obvious.
They're in one box.
I mean, it's obvious.
Pushing. No work.
Why though?
Because they're in a box and they're trying to push the wall, but they cannot push the wall.
It's nothing to push. So you can't push the wall.
If you
unless you use the Hulk.
Work. The Hulk. Work is force times distance in the direction of the force. So the distance here is going to be 0. So work will end up being 0. And so the answer is definitely
you just put an effort for nothing.
Yeah. Okay, so I just looked it up, right? And this is actually a fuse, not a circuit breaker. A circuit breaker also could protect a device from overload, but a fuse also does it. So this is a fuse.
So what is A?
Switch.
Yeah, it's basically a switch. This is a battery. C.
Circuit is C. No, bulb.
I'm not sure.
I think it's a bulb. I think it's a bulb. I don't know.
But I know this is a fuse, battery, and a switch. Okay, what form of energy is produced when you rub your hands together? Is it A, friction, B, heat, C, magnetic induction?
Friction.
I rub my hand together. Heat. B.
Friction.
B. Friction.
What form of energy?
My hands get hot when I rub my hand together, so I
friction.
Form of energy. Form of energy. Not
energy.
Heat.
Heat.
Oh.
Heat. Heat. Okay. All right, number 30. Which water sample is likely to have a high salinity?
What is that? What is salinity? I don't know what that is.
That's like high salt content.
Tap water.
Seawater.
Seawater. Sorry.
Seawater. Yeah. 30B. Yeah.
Tap water do be salty.
But it says we're talking about the highest now. So
yeah, heartburn.
So it's B. Which process is an example of oxidation? Is it boiling water, breathing air?
What's that oxidation? What's that?
Oxidation. What is that? Explain.
Okay, oxidation is. Give me one moment. Okay, sorry, my bad. I had to speak with someone. Okay, so yeah, so oxidation is defined as
the atoms changing.
Not atoms. Close though. Not atoms changing. Start with E. Something is lost.
Electrons.
Electrons what?
Is lost.
Electrons is lost. So oxidation is the loss of electron. All right. Now, there's something that is the opposite of oxidation when you gain electron. And what is that?
Neutron.
Say it again.
I know that's right. So I guess to say neutron, whatever it is.
Atoms.
No.
What it start with?
Positive, negative.
No, it start with R.
Radiation.
Hey, Finn.
Not radiation. It start with R, reduction. So you have oxidation and you have reduction. So let me just show you oxidation versus reduction. So remember, oxidation is so good. This is a good picture. Oxidation versus reduction. So oxidation, we lose electrons, right? Reduction, we gain electrons. For oxidation, it causes an increase in oxidation in oxidation state. For reduction, it causes a decrease in oxidation state. For oxidation, it's an addition of oxygen, and for reduction, it's removal of oxygen. Okay, so here we have sodium, and this is a chemical symbol for sodium, right? And if you lose an electron, right? If you lose an electron, it becomes more. If you lose an electron, the thing will become more positive, because if you think about it, if it's kind of a weird thing. Like if I am losing an electron, right? I am basically becoming more positive. So like if I had 9 electrons and I move one, now I have 8 electrons. That's basically like adding 1 to it, because it's like -9 plus 1, right? Because I lose an electron. So oxidation is going to be losing electrons, and that happens. And a good example of that is when you like rust in iron. That's a good
So
example.
electrons are bad then.
No, not necessarily, It depends. Sometimes we sometimes we would want to lose. It depends on how. Okay, let me see. Let me see if I can explain it. We have these elements, right? And their ideas that they want to be stable. In order for them to be stable, their outer shell must be full. So sometimes, in order for them to be stable, it is better for them to gain an electron, right? Because when they gain electron, if they had 7 in its outer shell, they need 8 to be stable. If they gain 1, then they become more stable. Now, sometimes it is better if they lose 1 electron, because sometimes they may have more electrons than they need. So if they lose 1, then that would make them more stable. So it depends on what state that they're in, right? So sometimes gaining is good and sometimes losing is good. So we wouldn't say that electrons are good or bad. It just depends on the element and how stable they want to be. Right?
Okay, I get it now.
All right, so 31 is rusting iron. That's oxidation. Number 32, the diagram shows a salt water. Which compound is the solute? So we have a salt water solution. Which compound is the solute?
B.
B? No, definitely not.
C. I mean D.
D? Who said D?
Gabriel.
No, it's not D.
A.
A.
It's not A.
C.
C.
And you only left with CA. But remember, they say salt water solution. Salt water solution. So because they say salt water solution, because they said salt water solution, you're dealing with salt. So salt plus water gives you the salt water. Now, the chemical symbol.
Sodium chloride.
Yes. The chemical symbol for salt is sodium chloride. And sodium chloride is NaCl. Okay, Na for sodium and Cl for chlorine. Okay, it's also important to know. So this is for sodium, this is for chlorine, and together they are going to form salt. So because it's a salt water solution, we know that the solute, and the solute is the thing that is going to be dissolved, right? And so the solute, which is salt, is going to be dissolved in the water. And the chemical symbol for that is NaCl. Okay. Number 33. Which layer of the atmosphere contains charged particles?
Stratosphere.
Which layer of the atmosphere contains charged particles? Eh,
A.
eh.
B.
B.
Oh my
It
God.
ain't tropos. I know that for sure.
It's A. It's A. Ionosphere. Right?
Why you say it isn't A?
Everything good, Mr. Petit. Everything good.
Just to, and that's the perfect way for me to know y'all guess it. It is A. A is the area that contains charged particles, and you could kind of tell because ionosphere. So ion, remember ion is a charged particle. So ionosphere. Number
And I
4.
gonna say stratus. Wow.
Yeah.
Tell me why I was thinking about the inside of the earth.
No, ions. So ions is positively or negatively charged particles. So ionosphere. Number 34. How does heat from the sun travel through space to the earth? Is it by
Radiation.
convection, expansion, or radiation? A, B, C, or D?
D.
D, very good. Like we said,
Yeah.
it is radiation. All right. Convection is heat transfer in a solid. Sorry, conduction rather is heat transfer in a solid. Convection is heat transfer in a liquid. Expansion, just expanding. And then radiation is heat transfer in a vacuum or heat transfer in space.
Do you think humans can survive without the sun?
Of course not. Why we can't survive without the sun? There's a major reason why we can't survive without the sun.
Die of hypothermia, maybe?
No. Why we can't survive?
Because if there's no sun, we're gonna like be cold and cold to death or something.
Cold, someone say because of the cold. But there's
Yeah.
something even more fundamental than the cold.
No fresh
It's energy.
air.
We
It's energy.
No fresh
We
air.
need sun without.
Go ahead, Michaela.
We need sun for plants, and if we don't have plants, how we can breathe?
Yeah, I was just about to say that.
Exactly. So we need the sun because the plants need the sun to live. And if there's no plants, and if the plants don't have no sun, then they can't make their own food because plants need the sun to for what?
So for thing what it called?
What's it called?
Photosynthesis.
Photosynthesis. Very good. So the plants need the sun for photosynthesis. If they can't do no photosynthesis, then no food. So you could be on this lonely earth by yourself, dark, and you're hungry. And so that's not gonna be a good thing, right? So yeah, we need the sun to live. Number 35. Which magnet is a temporary magnet? Is it a bar magnet, electromagnet, lodestone, or refrigerator magnet?
Bar.
You say R?
Bar. A.
Bar? No, definitely.
C.
Temporary magnet. Temporary.
D.
B.
D. I said D.
Electromagnet.
D as in boys club. Electromagnet.
Electromagnet, but it's a refrigerator magnet though. You could take it off.
No, it's no, they don't mean like that. It's still a magnet either way because a refrigerator magnet remains a magnet. An electromagnet is a magnet that is induced by electricity. So that means that when you turn the switch on, the magnet is on. When you turn the switch off, the magnet is off. That's electromagnet. So they like to bring that. The lodestone Lodestone is what we call a naturally occurring magnet. All right, it's lodestone. Okay, number 36. Which phrase do not describe a hurricane?
A.
Let me read the say A. Just because Baselinas be wrong sometimes doesn't mean.
Yeah, for real.
All right.
That's why I said.
Which phrase do not describe a hurricane? A, can be predicted and tracked by meteorologists. B, forms over water. C, is a funnel-shaped cloud. Or D, may cause storm surges, heavy rains, and strong winds.
C.
Number 36 is C. Yes, it's C.
But Basil getting too old, man.
Funnel-shaped.
Switch him out.
Say.
See, I mean, well, let me not get into that. At all. Number 37. Which drawing represents the Cyrus cloud?
What?
Which drawing represents Cyrus cloud?
What that mean?
I don't know this, but I'll take a guess.
Okay, I'll take a guess too. I feel C.
You feeling C?
I feel C also.
I feel A, but
I'm feeling D.
I feel C because C look like a cloud that come out of an explosion. So
I would say A. I know.
You'd say A? Who's A? Who's saying A? That's what? Deshaun?
Me.
Yes,
Okay.
Hey,
Whoever said A is correct.
I look like a mountain.
Oh, yes, sir.
I was thinking that at first, but I was like, that looked like the C.
Boy.
Cyrus cloud. Now, what are Cyrus clouds, right? So let me show you Cyrus. Cyrus clouds by definition. So there they are. They like the scrapey, like basically. They are made of ice crystals. They look like long and thin, wispy white streamers in the high sky. All right, wispy white. That's it. That's like they look silky and scrapey, right? Thin and wispy, right? Look at them.
Look at them air symbols.
Do you see how they look long, thin, almost look like scroll
Yeah, it is me up in the sky, occurring all the time.
High altitudes. Cyrus. Okay, this is A. Which diagram? Oh wow, you didn't even tell me it's past 8:30. We need to go to general. We need to go to health.
Why didn't realize that?
Why I realize I need them?
Okay, so
A.
We need to go to health science. So we coming back to number 38. Let me come back. So remember that we stop at number 38. So number 30. So now let's go to health science. Health science.
I don't like health science.
Come on, health science. You should be.
That's the easiest one.
Well, I just don't like it.
I passed in 1 month.
Please send me the photos of what I want you to write. I wanted you to write the number and the letter. That was correct. So number and letter. So send me a photo of that. The number and the letter. I bet you half of y'all didn't do that.
I have to find my pen.
The number and the letter. Okay, so where will we end this one?
Number 20.
We stop on 20.
Okay, thank you. You reach all the way to 20? Wow. That's amazing. All right, so number 21. Which process occurring in the digestive system allows feces to pass out of the body?
Assimilation.
No, man.
Digestion.
To pass out.
Digestion.
Digestion means what?
Let out all the substances out.
Like excretion or something?
Yeah. Ingestion. What is ingestion?
That's when you eat the food. That's the substance of putting things in the mouth.
Yes. Digestion. What is digestion?
When everything is breakdown
Yeah,
by the enzymes.
Yes. And what is assimilation?
I have no idea.
When the food mixing up, I guess. I don't know. Going down the pipe. I don't know.
No. No. Anyone else? Assimilation.
When food.
When the digestion come back up?
No. When the food is absorbed, right? So when the nutrients is absorbed.
And takes in all the nutrients.
Yeah. Right.
So that's where absorption come from.
Yes. That happens in the small intestine. Because I mean, the food you could take in the food, you could even break it down, but what if you never absorb the nutrients? Then how you gonna live?
Yeah.
True.
So,
what if you eat food with no nutrients?
Say it again.
Okay, I want to know if there's a type of food on the earth that has no nutrients. So.
Absolutely no nutrients. Well, you have food that are low in nutrients, right? But no food don't have no nutrients in it. We can't make that case. But you know, some foods are so low in nutrients that we just say it doesn't have any. That's how low it is. You know what I mean? Like for example, waste, right? Waste. I mean, if you eat that, I mean, what nutrients you can get? I mean, that's waste. I mean, it's so low in nutrients that it does more harm than good. So we say has no nutrients at all. I mean, of course it has some, but that some is not really good. So it's like, yeah. Anyway, number 22. The diagram shows the tongue. Which area detects the bitter taste?
B? Definitely D. That's
B?
B as in what?
I feel like boy.
Huh.
I feel like whenever I eat something, it's to the front of my mouth. So I feel like D.
It'd be D.
B or C?
Say it again.
B or C?
B or
I think it's A.
B or C?
B or C.
I think it would be D, like dog.
This is 2014, right, people?
Yes, sir.
Okay. Number 22. Bitter taste.
B.
No.
A.
B.
It's D.
D.
It's A.
A.
What? A.
It going halfway to the throat. That's why. Got it.
It's A. I knew it was A because I was taking some medicine and it tastes like spoiled strawberries and rubbing alcohol, and I felt it right there.
You know how alcohol tastes?
That's how I would imagine it to taste.
By the smell.
Okay, so look, taste and the tongue. So I think this will help you. This is a good one for you to see. Look where we are. Just out it. Look where bitter is.
Oh, should have two images.
Got it.
Yeah, bitter is in the back. Yeah.
I can take a picture of that, please.
Go ahead, no problem. Sour is here. Sweet.
Most definitely.
Salty is there now. You, mommy, boy, I hate these ones. I hate tomatoes. Anyone like tomatoes?
No, sir. I hate that.
If you cook them properly.
Wait, why y'all
cook properly?
I hate that, but I usually eat that in omelet. That's the only thing.
Like I mean,
why y'all taking on my favorite thing? Why are y'all taking on it?
Favorite? I mean, if you stir fry it, I guess.
They make good omelet. I can give props to that.
That and cucumbers the only things I can eat.
What?
Cucumbers.
Wait, now, bro.
What?
Those are the only things that don't taste like
broccoli.
Disgusting.
Wow. Number 23. What eye disease causes the lens to become cloudy or milky?
D.
Night blindness.
D. No.
What you mean by cloudy or milky? What you mean by that?
Cloudy or milky?
Like if it blurry.
It can get more blurry and look
So be the myopia, whatever that word is,
myopia.
Be like boy.
or glaucemia, coma,
Eh?
something like that.
Glaucoma.
Maybe.
Yes, B, glaucoma.
Yeah, B. Yay.
So glaucoma causes the eye to cause the eyelids to become cloudy or milky. Glaucoma. Always remember that. All right. That's an eye disease. Cloudy or milky. That's
How you get it though?
I don't know. Probably inheritance. I don't know. How we get glaucoma? Let's see. How does a person get it?
Face too close to the camera.
No, definitely not.
No.
Phone.
Say phone.
I mean phone, not camera.
Eating too much. Eating too much tomatoes.
Tough.
Too much
Tough.
tomatoes.
It just says a damage in an octave nerve.
How's that possible?
Too much pressure. High pressure. Oh, maybe because oh, like if you have diabetes, it could lead to that. Okay.
Oh.
I see. So if you have,
I know diabetes is affect your foot.
it does. If you ever see people who have diabetes and they kind of blind too.
You get their foot off.
It would be dead itchy.
Yeah. So, what causes glaucoma?
So I guess my cat had diabetes. Then
Medication. High blood pressure could also do it.
wait.
What?
Wait. They say
So blood pressure could just cause literally every problem in the world.
Yeah.
Wait. So they say redness in the eye too.
So if you have diabetes, that could lead to glaucoma, and if you have high blood pressure, that could lead to glaucoma.
Boy.
That's a triple on the side, man.
Yeah. So, be careful, little Miles, what you eat. Anyway, Jerry has soft, deformed bones. What is the name of the disease caused by this condition?
Rickets.
No.
Rickets.
Rickets.
That was the most easiest one.
Well, I don't know what that is.
Well, now you know.
When your legs
bones to be
your bones that's off and brittle. And brittle.
Our newborn babies had is because soft though. Oh goodness.
All right, number 20. So number 24, remember it's rickets. See, rickets. Number 25. Which of the following may occur if you cut your skin and bacteria gets into the worm?
Infection.
Infection, yes. 25. C. But we are not 25? Yeah, 25 C. Infection.
The answer for C is 26 is C.
How are you getting 26 already? We are now 25.
Wait,
my bad.
Again?
24 was rickets. C. Now 26 now.
C.
Which row in the table correctly shows the blood group of a person that
C.
can be given to any other person during a blood transfusion?
A.
O.
C.
C.
O.
They could give to any other person, so that's O. The blood group O can give to any other person. Who's anyone have a blood group of O here?
My
I
dad.
have no idea.
I really don't know.
Whatever blood my dad have, that's what I have. I don't know.
I know that.
Number 27. What is the function of the platelets found in the blood?
D.
D.
To stop bleeding. Yes. Platelets.
Yes, sir.
Stop bleeding or clot blood.
Or repair cell damage.
Okay. So I have a question.
Go ahead.
So if it's O positive, that still you could give it to anybody?
Yeah, I think so. I think so.
Well, I guess I could give my blood to anybody then.
Yeah, I think so. Oh, it's still in the O group. Number 28. The diagram shows a cross section through a blood vessel. What type of blood vessel is shown? Now notice, right?
D.
And
Wait. Oh.
notice it has a.
That's B.
Notice it has.
A.
It has a
What's up?
large.
Girl, let the mom
It has a
finish.
large lumen. This ain't small. Let's look at more.
Artery?
It has elastic fibers. Okay, yeah. Okay, so it's elastic. It has elastic fibers and smooth muscles, and its lumen is. They should have done a better job at this. But its lumen is.
Mental.
The lumen is small though. It's supposed to be small.
So what about that big one?
I know
That
it's
look
huge, right?
cute.
I know it's huge, right? It look huge, but relative to the other ones, it should have been bigger. So like it should have been the size of this one, right? But because it's smaller, it's this. So it has a small lumen, it has elastic fibers and smooth muscle. What is this?
Capillary?
No, sir, definitely not.
A.
The capillary. Wait, no, vein.
A.
Artery.
A.
So I was right the
What
first
a
time.
sick.
Yeah,
I
artery.
knew it.
Vein
The
has
capillary.
vein
Capillary.
is a blood vessel. Vein is a blood vessel that has a large lumen and it has valves. All right. But artery has thick, elastic, um, um, muscular walls, right? And it has a
and
small.
capillary one cell.
Capillary is one cell, so there's the differences for the artery, vein, and capillary. So this is a diagram to show you the three. I just had it right now. So as you can see, it has a small lumen, a thick outer wall, all right, and a thick layer of elastic fibers. That's the artery. So it's designed such that it could take high pressure, right? But if you look at the vein, you see how big this lumen is, very large, right? But look at its walls, it's very thin, okay? Very thin walls and thin layer of elastic fibers. This is the vein. And vein has valves too. Capillary is only one cell. It has a very small lumen. It's made of a single layer, of cell. So that's the difference between these three blood vessels. So again, this is them again. Single cell wall, thin wall, large lumen, and has valves. Thick elastic wall, small lumen. This is your artery, vein, and capillary. Okay, so that's the difference right there. So the correct answer here is A, artery. All right. Number 29. Which flow diagram correctly shows the direction of the flow of carbon dioxide as it passes through the respiratory system into the air
C.
outside the body?
C.
D. But you mean inside? Hold on.
Oh,
Wait, out
D,
the body. You mean out the body? D. D then.
D is incorrect.
Yeah, it's going out, right? Yeah, out.
B?
D is incorrect.
C.
A?
C.
It's A. And I'm explaining to
A.
you. Yeah. So let's look at the respiratory system. So if we look at the respiratory system, right? What we have is let's take a deep in. You see these? Let's go in some more. You see these little small little branches, right? We call
They look
them,
like tree branches.
yeah, we call them the bronchioles. And inside them, if you zoom in some more, we have what we call the alveoli. So the alveoli is these air sacs. So if I want to show you them, alveoli. Anyone ever saw alveoli before? We did this before.
When was last I spelled?
I saw them in grade 6 before.
So this is alveoli. So alveoli are these air sacs. They are connected to the bronchioles. So this is it right there again. So here we have the alveoli. So what you have here is you have the alveoli, carbon dioxide, because remember carbon dioxide is trying to come out. We don't want carbon dioxide. So carbon dioxide is gonna start from this alveoli, and it's gonna go into the bronchioli. Then after it goes from the bronchioli, then it goes into these some more bronchioles. These are the branches of your these are the branches that are inside your lungs. So it goes and then it goes to the two bigger branches, which is the bronchus. So from the alveoli at the back, going all the way to the bronchus, these two, right? Then it goes to the trachea. Then from the trachea it goes into the nasal passage and out through the nose. So the same thing with this, which is what it's saying. It's saying, okay, it's going to go from the alveoli, and it's going to go to the bronchioles, then it's going to go to the bronchi, then it's going to go to the trachea, then it's going to go out through the nose. Okay, so the correct answer here is A. D cannot be correct, because how would it go from the trachea to the bronchi? Remember, trying to come out. So we'd have to start from the alveoli, then go to the bronchioles, then the bronchi, then the trachea, then the nasal passage, just like this. So again, alveoli, these air sacs, then bronchioli, these small little tubes right here, then the bronchi, which is these two main tubes here, then the trachea, then the nasal passage.
So C is when air coming into the body then?
Yeah, C is when air comes into the body. So C is, it goes into the nose, into the trachea, then the bronchi, then the bronchioles, then the alveoli.
At first, I thought it was C until I realized it's C when it goes out into the air.
You're talking about carbon dioxide, and carbon dioxide is something that you want to come out.
So yeah.
It can't be C. All right, so
yeah.
That process is happening faster.
Yeah, it's happening fast. That's correct. Okay. All right, so this is going to be our last one before we go. Let's stop at number 30. So the equation represents the process of respiration in the body cells and tissues. What do the letters X and Y represent?
The letters who?
X and Y. So X and Y. What does that represent?
Carbon dioxide
and glucose.
A. Yeah, it's A. No, it's
C.
I know it's glucose for the last one. So C.
C? Okay, so first of all, we're talking about respiration. Respiration is going to be when we take in oxygen, right? And our bodies use it to basically generate or to give us energy. Now, when you take in oxygen, it needs to be in the presence of glucose. So X is glucose. And then once you have glucose and oxygen, you're going to produce water, a gas called carbon dioxide, and energy. So again, the respiration equation is glucose, oxygen, water, carbon dioxide, and energy. So based on that, what is the that is X and Y?
B.
Glucose and
B.
Carbon dioxide, which is B.
Yeah, B. And this happens in your cells. Okay? So that's why it's important when you're running to breathe, because if you could breathe, then you get more energy. So that's why I say breathe, breathe, breathe. And so that's why when you run, you find that you breathe in heavy, because your body trying to get in oxygen. All right.
I feel like when I in track, when I trying to breathe while I running fast, like I feel like that slow me down for some reason.
I know what you're talking about.
I was doing that today, Mr. Petit, while I was running. Like that wasn't working. I was
Especially
trying to
playing ball.
and I feel like it was making me slower.
Yeah. Take deep breaths. So in and out. I know it takes a while to really get used to it, but
That's be me and the ball.
Yeah.
Running around, shoot it, get learn how to
I came
breathe.
as well. That's being running up and down the court.
Yeah. I hope you don't miss the shot after a lot.
Never.
Very cool.
Listen to you, Holly.
Never.
Y'all have a good night.
Good night.
Bye.
All right. Good night. Good night.
All right.
Bye.